We were working on 12.2 second derivative of n graph before spring break. So just a quick reminder, if we take the first derivative and equal to 0, that's the part that you can find the critical number or the changing points, because if you have increasing, going decreasing, like that, a lot of time that would be a maximum. That would be a relatively maximum at the critical number, right? And if we have going down and then back up, then you have the relative minimum points at your critical number. But if you have just continue to decrease or increase when you take the first derivative, then it means it's not a critical number. You don't really have maximum or minimum point. So that's for the first derivative, which is in 12.1, right? We have 0, positive, negative. So on 12.2, we are looking at the second derivative. If you get a positive number for the second derivative, positive number, positive people usually smiling, so your concavity is kind of look like a smiley face like that, or sometimes you may just have part of it on this side or this side. So concave up is when you're taking the second derivative and you get a positive number. Concave up like a cup. So the shape like a cup or a smiley face to help you to remember it. Okay, and if you take the second derivative and you get a negative, and negative people usually is kind of sad all the time, so you look like a sad face for your concavity. And you may have just part of it. So concave down, it's going to like a smiley face, like that. Okay. But if you get a 0, then it's going to be inconclusive. We don't know it's concave up or down. So last time we looked at those pictures, we can see the function is increasing between A and C. But it looked like it changed the shape a little bit at point B. So we're going to say the graph behavior change at point B. So it started with concave up like a cup shape, and then change to concave down like a frowny face, which means even though the function keep increasing, the speed of its increasing is going to change. So it's faster, the second derivative, positive here, concave up, and then at B it turns slower. So it could be like you're selling a product at the beginning, it's popular, you sell a lot, and then it kind of slowed down because most people already bought it, but it's still a popular product, something like that. So we can say the function is increasing between A and C, concave up. If the slope is increasing, the derivative increase as x increase at A, and then you have concave down if the slope is decreasing, and then the derivative is decreasing at that point also. All right, so hopefully you still have the handouts with you. I know it's kind of tiny. Hard to see from my okay, so the next one also go up, but it looked like it's changing. The speed of increasing again at B is increasing between A and C. So it kind of go like this, and then it changed to that. So it's changing from concave up to concave down at the point that is changing, which is the B point, is called inflections point. So inflections point could be concave up to concave down, or concave down to concave up. Okay. So let's look at the next page. So the next page, you may have exam questions like that, and it may sound easy, but it's very easy to make a mistake also. So we want to find an interview where the graph F is concave up and where it is concave down. So remember, concave up is like a smiley face, concave down is like a frowny face. So I can see this look like a sad face here, right? So between here to here, it looks like it's going to be concave down. How do I write that? In terms of x, we have starting from negative infinity to x equal to 0. It's like a frowny face. And then starting from x equal to 0 look like a smiley face, right? So the starting from 0 to infinity is going to be concave up. So the inflections point is the point that's changing the concavity, right? So it looks like it's going to be here. So I'm going to say 0.00. Are we okay? If you want to, you can stop the video and try some of this. Again, it's kind of easy to make a mistake, so be extra careful. Okay, for number 2, again, concave up, concave down, inflections points. So it looked like starting from here to like here is concave up, and the inflections point look like change about here, maybe around here. So concave up is starting from maybe 1.5 to infinity. Oops, sorry. 1.5 to infinity. And then concave up is this, concave down is going to be starting from x's 0 to 1.5. So we're focusing on left to right in terms of x when we do increasing and decreasing, or concave up, concave down, right? And the inflections point is a point, so about here and here, so maybe 1.5 for x and 2.5 for y. Are we okay? So if you have a question, like, you can certainly email me. I would suggest you pause the video and try number 3 and number 4, and then you can turn it back on and we can try to check your answer. So if you're ready, look like this and this are both concave down like a frowny face, right? Can you see that? So concave up, we don't have any. Concave down is starting from negative infinity to x equal to 0, union, starting from 0 again, and positive infinity. How about the inflections points? If they didn't change concavity, then we have no inflections point. Remember, inflections points have to be changing concavity, and we don't have concave up to concave down, and we don't have any concave down back to concave up. Are we okay? Okay. You can try the next 2 and we can check your answer in a few seconds. You can pause the video if you want to. Okay, looking at number 4. Again, it looks like all of them are concave down, 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 down. So concave up is none, concave down is negative infinity to x equal to negative 2. And then starting from negative 2 to 2, starting from 2 to infinity. All right. And what is the inflection point? Again, we don't have concavity change, so it's going to be none again. All right, the last one look kind of weird, but this look kind of like concave down, right? This kind of look like concave up, right? So concave up starting from x is 0 to infinity, concave down starting from negative infinity to 0, and the inflection point is x is 0, y is positive 1. Okay. So hopefully you try a little bit and you may see how challenging this can be because we probably will have some like this on the exam.